Geometry class, this is Mr. Ryan again. This is now for Wednesday, April the 1st. So we're gonna just keep going each day and just keep up with me each day. Remember, get your notebook and your calculator and your book so that you can keep right along with me and write this out with me, please. So today is 11.3, Similarity within right triangles, starting on page 553. And so we are going to start with this triangle that we'll use throughout the class, triangle ACB, which has a right angle on top at angle C, and then the altitude CD comes down at a right angle to the base AB. So now we're going to find the right angle altitude or right angle height theorem, and we're going to prove it. Given right triangle ABC with altitude CD, prove that ABC, the big triangle, is similar to ACD, the left triangle. Okay? So as we used to do last semester a lot, in our statements we have one, the right triangle ABC with altitude CD is given, and CD is perpendicular to AB because it's an altitude, definition of altitude. That angle ADC is a right angle, definition of perpendicular, where I have it marked as right. And ACB angle is congruent to ADC because they're both right angles and all right angles are congruent. And angle A is congruent to angle A, of course, by reflexive property. Therefore, making two corresponding angles congruent and making ABC triangle similar to ACD triangle by AA similarity. Now, to get us ready for our theorems, we're going to, in example 1, find the geometric means between each pair of numbers. So to do a geometric mean between 3 and 27, notice, we set it up as 3 over x equals x over 27. So the 3 and the 27 get multiplied on the cross multiply. So as we multiply, we get x squared equals 27 over 3, x squared equals 81, the square root of 81 is 9, so x equals 9. And to find the geometric mean between 6 and 9, we set up 6 over x equals x over 9, x squared equals 6 times 9 or 54. Now when we square root 54, we want to look at the square root of 9 because that comes out as 3 times the square root of 6, so x is 3 square root 6. Now our first altitude geometric mean corollary, which is really about the height, is set up as x, the left part of the base, over h equals h over y. Notice that geometric mean setup where h and h get multiplied together. Now for leg geometric mean corollaries, we're going to look first at b and then at a. So to set up for b, we do x over b, the left part of the base over that b leg, is equal to b over the whole base, x plus y added together. Now for the right side, we have y over a, the right side part of the base over a, is equal to a over the whole base, x plus y. And now looking at example 2, where we're going to use these, look at our triangle, where we have triangle RST, with the two parts of the base being 4 and 16, the height, the leg T and the leg R not being known. So to set up for the height, we're going to do 4 over h equals h over 16, or cross multiplying, h squared is 16 times 4, 64, square root of 64 is 8, so h is 8. Now to get the leg T, we're going to do our 4 over T is t over 4 plus 16, or 4 over t is t over 20. So cross multiplying, t squared is 80, and t squared, t is the square root of 80. Now let's look at how we prime factor that to get the perfect square out. So 80 is prime factored as 8 times 10, 10 is 2 times 5, so grouping 8 and 2 together, we get 80 is 16 times 5, and that's what we need for the square root of 80 to be the square root of 16 times the square root of 5, so we can take that out as 4 square roots of 5. Now to get the leg R, we're going to do 16 over R is equal to R over the whole base 20. And cross multiplying, R squared is 320, Or now, prime factoring 320 will take 32 times 10, and 10 is 2 times 5, again showing that 32 times 2 is 64, a perfect square, which is what we want, the biggest perfect square. So therefore, we can square root 320 as the square root of 64 times the square root of 5, allowing us to bring out 8 times the square root of 5 for r. Okay, now for example 3, we have a 512 triangle with another right triangle on top of it. But the main thing to note is that the parallel line A is parallel and equal to 12. So A is 12, the top, and 5 across to the side to the right is the same as x. So A is 12 and x is 5, giving us 3 of our unknowns on the big triangle, A, x, A, y. So using our height geometric mean, x over A is A over y, so 5 over 12 is equal to 12 over y, giving us 5y is equal to 12 times 12, 144, and 144 divided by 5 is 28.8. So now to get the total height, we would want to add the 5 from the base up to here, and then the 28.8 up to here. So that would give us 28.8 plus 5 is 33. Now in our homework, we're going to again get the geometric means between a pair of numbers 3 and 27, which I think we've done, which would set up as 3 over x is x over 27. X squared equals 27 times 3, or 81. Square root of 81 is 9, so x equals 89. 9 is the geometric mean between 3 and 27. Now to get the geometric mean between 1/2 and 1/8, we do 1/2 over x is x over 1/8. X squared is equal to 1/2 times 1/8, or 1/16. And the square root of 1/16 is the square root of 1 over the square root of 16th, which makes x equal 1/4. Now using this triangle, which we did on the examples, with the big right triangle with the right angle at the top and the altitude coming down to the base at D making a right angle, we proved that the big triangle ABC is similar to the right triangle ADB, but it's also shown in the book to be similar to the right triangle BDC, this triangle on the right. Now for 8, we have again the same setup for the right triangle with the altitude down to the base. We have 2 parts of the base, 4 and 12, but this time we're going to get the leg x. So we get the base on the side of x, 12 over x is equal to x over the whole base, 12 plus 4. So x squared is equal to 12 times 16, or 192. And looking at the prime factoring for 192, if I divide by 2, I get 96, which isn't too helpful. But if I divide 192 by 3, I get the perfect square 64, and that's what I need. So I'm going to take the square root of 192 to be the square root of 64 times the square root of 3, or 8 times the square root of 3. Okay? Now in problem 10, I have my basic triangle set up with the 2 parts of the base being 7 and 6. And to find the height as the geometric mean, I'll do 7 over h is h over 6, or h squared is 42. And we can just actually use the square root on that and get 6.5, and that would be fine. Now to find the leg t, remember we'll do the base on that side over t is equal to t over the whole base, 7 plus 6. So t squared would be 7 times 13 on the calculator would be 91. And we can just do the square root of 91, which is approximately 9.5 to 1 decimal point. Now to get the other bottom leg r, we'll do the base on that side, 6 over r is equal to r over the whole base, 13. So r squared is 6 times 13, or 78, and then r is the square root of 78, which we can just take as 8.8 to the nearest 10th. Okay, looking at 12, we have our basic triangle with 2 parts of the base being 15 and 5 with the same setup. So to get the height, we have 15 over h is h over 5, or h squared is 15 times 5, which is 75. And the square root of 75 is easily recognized as 3 times 25, And that gives us the perfect square so that we can take out 5 and make it 5 squared roots of 3. Now to get the leg x, I'm going to take the base on that side, 15 over x, is x over the whole base, 20. And so x squared is 300, and 300 is easily broken apart as 100 times 3, so that we can get the perfect square out as x being 10 times the square root of 3. Now to get the leg above the 5, I'm going to do 5 over y is y over 20, or y squared equals 100, making an easy square root of y equals 10. Now on 14, I have a 512 triangle with a right triangle on top of that, but the important thing to note, like we did before, was that h is parallel and congruent to 10, so h is 10, but 5 over to the right side is the same, parallel and congruent as 5. So to get the height on the big triangle, we're going to do x over h is h over y, which becomes 5 over 10 is 10 over y. So 5y is 100 and y equals 20. And again, adding the 5 at the base like we did before, we're going to add 5 plus 20 to get the total height of 25. Okay, now for 16, they ask us to get the geometric mean between square root of 3 and square root of 27. So remember our normal setup. That'll give us x squared is square root of 3 times square root of 7, or x squared is equal to the square root of 81. The square root of 81 is 9, and then we take the square root again now, so that the square root of 9 is 3, because we had to get the square root of 81 first to be x squared. Now, the geometric mean between a and ab squared is a over x equals x over ab squared. Cross multiplying, x squared is a squared b squared, which makes an easy square root of ab for x. Problem 20 has it's a little hard to see maybe, but the altitude or the height is 2 square root of 6, and the right side of the base is 4. So to get the height, using the height geometric mean, we do 4 over 2 square root of 6 is 2 square root of 6 over the left part of the base, y. And when we cross multiply, we get 4y is equal to 2 times 2, which is 4, and the square root of 6 times the square root of 6, which is 6. So 4y just equals 4 times 6, and then dividing by 4y equals 6. Okay, now to get the side a above the base 4, we have 4 over a is a over 10. A squared equals 40, and just 4 times 10 is the right way to do that, because the square root of 4 is 2, leaving 2 times the square root of 10 for our a. And for the base b being above the 6, because we found 6 when we first did our y for the first part, we can say that 6 over b is equal to b over 10. And so b squared is 60. And again, this time we'll use 4 times 15, because that's going to give us 4 as the perfect square to come out as 2 square roots of 15. Now on 22, we still have our two parts of our base being 6 and 4 with our same setup. Our height is 6 over h equals h over 4. H squared equals 24. 24 is 4 times 6, so the square root of 24 is the square root of 4 times the square root of 6, or 2 times the square root of 6. And if we put that in as the calculator, square root of 24, it would be 4.9. Using the same triangle, if we have AB equals 16, the whole base, and DB equals 5, that would make the other part of the base AD equals 11. So now, getting the leg AC above the 11 over AC is AC over the whole base, 11 plus 5, 16. So AC squared is 16 times 11, or 196, and we can simply put that in the square root on the calculator, and that comes out to 1 decimal point is 13.3. Okay, now for the last problem, we have the same setup, just knowing now that in general the two parts of the base are x and y. So to find AC, the leg above x, we do like we did. X over AC is AC over x plus y. AC squared is x times x plus y. And AC would just be then the square root of x plus y. That's all we can do with it. Then to find x over CD, the height, is equal to CD, the height, over y. So CD squared would be xy, and CD would just be the square root of xy. Okay, and then to get the part of the base y over BC is equal to the part of the leg above y. Y over BC is BC over x plus y, the whole base. So BC squared is y times x plus y, giving BC equals the square root of y, x plus y. So God bless you. Have a good day. And I know most churches are closed, but have a devotional. Please stay close to the Lord, and we're asking Him to protect all of our students. And I'm asking Him to protect you guys and keep you safe and healthy. God bless you and have a good day. Mr. Ryan out.